Welcome to myprojectbazaar.com.
Now we discuss about implementation of self-organizing approach to background subtraction for visual surveillance. Visual surveillance is a very active research area in computer vision thanks to rapidly increasing number of surveillance cameras that leads to a strong demand of automatic processing method for their output. The scientific challenge is to devices and implement automatic system able to detect and track moving objects and interpret their activities and behavior. The need is strongly felt worldwide, not only by private companies but also by governments and public institutions with the aim of increasing people's safety and service efficiency. The usual approach to moving objects detection is through background subtraction that consists in maintaining an up-to-date model of the background detecting moving objects and those that deviate from such a model compared to the other approaches. This approach is computationally affordable for real-time application. The main problem is it is sensitivity to dynamic scene changes and the concrete need for the background model adaptation via background maintenance. Such problem is known to be significant and difficult. Some of the well-known issues in background maintenance that will be specifically addressed in the sequel include light changes. The background model should adapt to the gradual illumination changes. The background model should include changing the background that is not of interest for visual surveillance. The background model should include the so shadow cast by moving objects that apparently behave itself moving. In order to have a more accurate detection of the moving object shapes, the background model should be properly stepped up even in the absence of a complete and static free of moving objects training set at beginning of the sequence. Moving objects should be detected even if their chromatic features are similar to these of background model. Our approach to moving object detection is based on the background model automatically generated by a self-organization method without prior knowledge about the individual. The idea consists in adapting biologically inspired methods for moving object detection, where visual attendance mechanisms are used to help detecting objects that keep the user's attendance in accordance with a set of predefined features such as gray level motion and visual will be given by quality and quantitative result that the out adaptive model can cope with all above mentioned issues for background subtraction. The proposed approach can handle scenes and camouflage as no boost stripping illumination can include into the background model shadows cast by moving objects and achieves robust detection for different types of videos taken with stationary cameras. We compare our method with other modeling techniques and report experimental results, both in terms of detection accuracy in terms of processing speed for color video sequence that represent typically switch critical for video surveillance system. Here we use two different types of algorithms for extract the background. One is the self-organizing approach, background subtraction is the SCSOPS, and another one is the paperwork of SOPS, self-organizing background subtraction. And finally we compare the both and which one is the best for background subtraction. It is the flow diagram for our proposed work. In this flow diagram, first we give the input video. The input video is our given video and that video will be converted to the frame. Here the frame converted is a process to convert the videos into set of images and then set an initial frame. The initial frame will help to identify the background and forward easily and then extract the neural map from the selected input frame and then load the second frame for subtraction background. Here the second frame also the neural map will be vector, and then counting the neighbor correlation factor will be identified for identifying the minimum distance maintained. If the minimal map will be minimum distance with compared to the selected frame and the choosing frame if it is acting as a background, or else it is go to the foreground for the images, and then the value will be checked and store the background and foreground by the nearest value, and then update the values, and then we again to select the another frame for the process to make it again and again. So finally the video getting the background subtraction as well. Now we going to demo of our process. First open the MATLAB source code and right click the main.m and then run the file, and then the process guide will be open. First browse the input video from the dataset. Now the video will be reader and then converted to frames. Here the frame conversion will be processed and also the frame will be counted here. There are 46 frames will be done here. After convert the RGB to HSP for each frame. Here we select the first image and then we extract the hue, saturation and also the value from the HSP image. Here the RGB will be converted to the HSP transformation. It is a selected frame, and then first we initial the weighted vector by using this selected frames, and it is the weighted vector of hue image, and it is the weighted vector of saturation, and it is the weighted vector of V. The weighted vectors are extracted, then we train the neural network for getting the background by easy way. The neural network will be training, and it is the graph for neural network training, and the train and validation test will be the same, so the performance of our process will be the 0.09%. Now we go to extract the background by using the SOPS algorithm, and here the process will be taking some more time, and it will be extract the background at desired level, and here the background subtractions will be running, and it is the background subtraction image of SOPS. And the background subtraction will be done by SOPS algorithm. The SOPS algorithm will be the existing method. Now we going to our proposed method SCSOP algorithm for background subtraction and compare to the existing one. Now we extract the background subtraction by using the SCSOP. And it is the background subtraction of SCSOPS, and it will take some more time for the process. And then visually compare the both SOPS and SCSOPS algorithm. The SCSOPS algorithm will be extract the background at a very well accurate level, because the SCSOPS working with based on the neural network classification. So the classifier correctly classify the background and foreground with desired level. And now click the analysis button to find out the performance of our classifier. Our classifier will be getting the 92% accuracy work, and it will be shown in the ROC curve also. Now it is the accuracy of the classifier is 92% and the sensitivity of the classifier is 0.96% and the specificity of the classifier is 0.88%. Thank you.